Hi students, welcome to this course again, an introduction to mechanical engineering. I am Professor Yao. Energy conservation and conversion. Machine produce power by burning fuel. Keyword: the conservation of energy. Automobile engines, jet engines, and electrical power plants. The chemical energy, gasoline, jet fuel, or natural gas. Mechanical work, the crankshaft rotation. Machines produce power by burning fuel. With the concept of energy, work, and heat in mind, we will explore the conservation of energy from one form to another. Automobile engine, jet engines, and electric power plants are three examples of machines that produce power by burning fuel. In particular, the chemical energy that is stored within the fuel, be it gasoline, jet fuel, or natural gas, is released as heat, which in turn is converted into mechanical work. In the case of automobile's engine, the mechanical work takes the form of the crankshaft rotation. In a jet engine, the output is primarily thrust for powering an aircraft. And in a power plant, the end product is electrical energy. Like many others, each of these mechanical engineering systems is based on the concept of converting energy from one form to another in as efficient a manner as possible. Principles of energy conservation and conversion. The keywords: principles of energy conservation and conversion with respect to surroundings, potential or kinetic and energy level. Principle of energy conservation and conversion. The principles of energy conservation and conversion are built upon the concept of a system, which is a collection of materials and components that are grouped together with respect to their thermal and energy behavior. The system is imagined to be isolated from its surroundings, so that it is separated from extraneous effects that are not important for the problem at hand. We take a very similar viewpoint in Chapter 3, when we use free body diagram to examine forces acting on structures and machines. In that case, all forces that cross an imaginary boundary drawn around the body were included on the diagram, and other effects were disregarded. In much of the same way, engineers analyze thermal and energy systems by isolating a system from its surrounding and identifying heat that flow into or out of the system. Work that is performed on the surroundings or vice versa, and the potential or kinetic energy level that change within the system. The first law of thermodynamics. The key words. The first law of thermodynamics. The process of conduction, convection, or radiation performs mechanical work. The system's boundary corresponding to. The first law of thermodynamics. At a high level of abstraction, consider the thermal and energy systems that is gauged in the figure 7.7. The quantity of heat Q, which may have been produced by burning a fuel, flows into the system. The heat can be transferred by the process of conduction, convection, or radiation. At the same time, the system performs mechanical work, W, as an output. Although heat and work both cross the system boundary, when they are represented by a positive numerical value, their direction of action differ. Heat is taken as positive when it flows into the system, and the work is positive while being performed on the surroundings. In addition, it is possible that the internal energy of system changed by the amount labeled as delta U in figure 7.7. The internal energy change could correspond to the temperature of the system being raised, in which case thermal energy is stored, to its kinetic energy decreasing, or to changes in its gravitational or elastic potential energy. The first law of thermodynamics states that these three quantities balance according to Q equals W plus delta U. Homework. Handwriting all keywords and submitting them to Course Facebook. Just do the online quiz and see you next time.